Okay, so you will have quiz today, and the quiz will start at 2:55 p.m. So you will have 25 minutes for finishing the quiz. Okay, so there is a question. So yes, I will post the review for the exam by this weekend, and I will also email you the review for the exam. And next class will be review class for the exam. So on Tuesday, you will not have any regular class. It will be a review class. So we'll go over the review problems in that class. So I will send you the review by this weekend and you will go over the review problems. So if you have any questions on the review problems, you can ask on Tuesday. Okay. So the probability function for the discrete random variable is probability mass function, and for the continuous random variable is called the probability density function. So the probability density function is denoted by f of x. Usually we denote it by f of x, and it is defined by, so if we want to find the probability of x less than equal a to b, so that's mean x is between two numbers a and b, then this probability is actually the integral of f of x from a to b. So what does it mean actually? Actually, we are finding the area of the density curve. So under the density curve between A and B. So that is the probability. So for example, if the density curve of f of x is like this, and suppose A is a number here and B is another number, then the probability between A and B is the area under this curve between A and B. So that's mean this area is the probability of X between A and B. And how do we calculate this area? So since the function for the density function is f of x and this curve is f of x, so you can just integrate f of x from a to b and it will give you the area between a and b under this curve. So when we discussed discrete random variable and its probability, I told you that for discrete case, probability at a specific number, that's mean probability x is equal x, it was not zero. But in this case, it will be always zero. So if you want to find the probability of x for a certain value, for example, x equal 3, then it will be 0. So that's mean if you the probability for the continuous random variable, the probability at a specific value of x is always 0. So why this probability is 0 for continuous case? Okay, so for continuous case, actually the probability is the area under the density curve. So uh, at a certain point, for example, if we want, if our x is somewhere here, so if you want to find the probability, so that's mean the area at this point, so the area of the line, and you know that the area of the line is 0. It doesn't have any area. For example, if you consider another density curve and a certain point, suppose this is x, so the area of this line is 0, right? Because the line has length, but it doesn't have any width. So if you cannot calculate that, you can calculate the area, but the area is 0. So that's why the probability is 0. Okay, so here you are given the probability of x between a and b. So this is the area under this curve, and the shaded region is the probability. So now the question is, what is the total area under this curve? Can anyone tell me what will be the total area under this density curve? Yes, I get to answer, and you said 1. Yeah, you are correct. You are right. So the total area will be 1 because you already know that the total probability of a random variable is always one, right? The total probability is one. So that's why the total area under this curve represents the total probability for this random variable, and it is always equal to one. So what will happen if for any function, if we get the total area is more than one, greater than one, then certainly it is not a probability density function, right? Because we know that under the density curve, the total area will be always one. Okay, so another thing, the density curve represents the probability density for all the values of x. So, and you know that the probability cannot be negative. So that's why f of x is always greater than equal 0. So f of x will be either positive or 0. So if you have a function which has this curve, for example, if you have a function and the function has this type of curve, this is not a density function, because below this line, the density is negative. So this part is negative, but the density curve cannot have negative values since this is probability. So probability cannot be negative. So that's why f of x will be always greater than equal 0. So this is not a density function. Okay, so if you are given a function and you are asked to determine whether the function is a density function or not, first you have to check whether this function is non-negative or not for any values of x, and you have to also check whether the total area under this curve is equal 1 or not. If it is not equal 1, then it is not a probability density function, and if it is not a non-negative function, then it is not a density function. Okay, so we already discussed this part. For continuous random variables, probability x is equal, any number is always equal 0. If you consider x is equal a certain number, then this probability will be 0. So now the probability between two values of x, so x greater than equal a, less than equal b, this is same as they are same. Why they are same in this case? Because we already know that. So what is the difference between these two notation? The difference is, in the first part we considered x is equal exactly a and x is equal b, but here we considers all the numbers between a and b, but we didn't consider the value a and b. Actually, in the probability, it doesn't make any difference, because we already know that at a specific point, at a specific value for x, the probability is 0. So that means the probability of x is equal a, exactly equal a is 0, and the probability x is equal exactly b is also 0. So that's why in continuous case, if you include the equal sign or if you do not include the equal sign, it doesn't matter. It will not affect the probability, because at a certain value the probability is 0. But in discrete case, you have to be very careful. They are not same. This probability notation and this are not same. They might have like different probabilities. And similarly, this is also equal x greater than equal a, less than b, and this is also equal probability of x greater than a, less than equal b. All of them are same. But this is for continuous case. But for discrete case, they are not same. Okay, so let's go over some example. Let x denote the amount of time for which a book 1 2-hour reserved at a college library is checked out by a randomly selected student. So x denote the amount of time. The amount of time could be any number, right? It could be 1 second, 1 minute, 1 point. Sorry, here we are considering hour. So it could be 0 hour, 0 0.1, 0 0.2, 0 0.3. So x can take any values, right? So that's mean x can take fractional values, it can also take the integer values. So that's why this is continuous random variable. And the function, the density function is defined by f of x is equal 0.5x and x is from 0 to 2. So the density function is defined only for the values of x from 0 to 2. For the other values, the function is 0. Okay, so now it is given that it is a density function. That's why you do not need to check whether it is density function or not. But if it is not given, and if you are asked to determine whether this is a density function or not, first you need to check whether this is always positive or not from 0 to 2. So the function is f of x is equal 0.5x. So if you plug in any value of x from 0 to 2 in this function, it will be always positive. So if you plug in 0 here in this function, then it will be 0. So for example, if you find f of 0, then it will be 0.5 times 0. So that means 0. And if you consider any values of x from 0 to 2, but if you consider a negative value of x, for example, if you consider negative 2, then it will be negative 5 times, sorry, 0.5 times negative 2. So that means this is negative 1. But the functional value is not positive. This is less than 0, right? But what do we know? We know that the density function is always positive. Now the question is it a probability density function or not? Anyone? Is it a probability density function? Okay, I get a couple of answers and you said no. So yeah, if you consider the negative value, the functional value will be negative, and we know that the probability density function cannot be negative. So you said this is not a density function based on this, but in the question it is given that this is a probability density function. So what's the problem here? Okay, the thing is that the probability function will be defined for a particular values of x. And for the other values for which the function is not defined, the function will be, you have to consider that the functional value is 0. So that's mean actually this function actually like this, f of x is equal 0.5x. And this is from 0 to 2. Otherwise, it will be equal 0. So this type of function is called piecewise function. And most of the time, the density function is a piecewise function. So that's mean for different values of x, it is defined in different way. So you can see here for 0 to 2, the function is 0.5x. And for the other value of x, the function is 0. So that's mean if you plug in any negative number, so negative 2, it will be always 0. Because it is given that for the other values of x, the function is 0. So in the question, they didn't mention it, but you have to consider that for the other values of x, the function is always 0, because this is a density function and the function is defined only for the values of x when x is 0 to 2. And for the other values of x, it is 0. So now the question is it a density function? How do you think? Will you change your answer or? Yes. Yeah, you are right. So this is a density function, right? Because for the other values of x, it is 0. So which is not negative. Okay. So now we'll go over, so we'll try to calculate some probabilities for this given probability density function. So how can you calculate this probability? So part A is probability x less than equal 1. So that's mean Okay, so the definition of the probability for the continuous random variable is probability of x less than equal x is always negative infinity to x f of x dx. So this is the general definition of probability for the continuous random variable. So here we have x less than equal 1. So that's mean minus infinity to 1 f of x dx. But in this case, for the other values of x which are below 0, the function is 0. So if you integrate from negative infinity to 0, it will be always equal 0, because if you integrate the 0 function, it will be always 0. So that's why you do not need to consider those values of x for which the function is 0. So that's mean actually this represents negative infinity represents the lower limit of the function for which the function is different. So what is the lower limit of this function? What is the smallest value of x for which the function has a positive value, or the function is not 0? So what is the smallest value of x? Anyone? What is the smallest value of x for which the function is not 0? Yes, 0, right? So that's mean the lower limit will be 0. And here we are given that x less than equal to 1, so it will be 0 to 1. And f of x is 0.5x dx. So now you need to integrate this one from 0 to 1. So if you integrate this one, then it will be, this is just a number, so 0.5. And if you integrate x, then it will be x square over 2. And x is from 0 to 1. So 0.5. And first you need to plug in the upper limit. So here the upper limit, this is called the upper limit, and this is the lower limit. So upper limit is 1. So first you need to plug in 1 here. So 1 square divided by 2 minus 0.5 0 square divided by 2. So that means 0.5 1 over 2 minus, here we have 0 here. So if you multiply 0, it will be 0. So then it will be 0. I think 0.25. So the probability is 0.25 in this case. Okay, so if you do not know how to do the integration, so I think you should learn this from college algebra class. Okay, so you need to know how to perform the definite integral. So the part B is we have to calculate the probability from 0.5 to 1.5. So probability from 0.5 x less than equal 1.5. So that's mean 0.5 to 1.5, and the function is 0.5x dx. So that's mean 0.5 x squared over 2, and x is from 0.5 to 1.5. Now first you need to plug in the upper limit. The upper limit is 1.5. So you will plug in this number here divided by 2 minus, you will plug in the lower limit. So the lower limit is 0.5 square divided by 2. So if you simplify this one, then it will be 0.50. So this is the probability. Do you have any question? Okay, so next question is part C is probability x greater than 1.5. Okay, so x greater than 1.5, so that's mean the lower limit is 1.5 and the upper limit is infinity, f of x d of x. So that's mean 1.5, and you know that the upper limit for this density function is 2, so it will be 2, and f of x is 0.5 x dx. So if you integrate this one, then the final result will be 0.4375. You have to integrate it and plug in the upper limit and lower limit and simplify it, then you will get 0.4375. Okay, so now I will, so now you can see the probability from negative infinity to positive infinity. Even in this case, you without any calculation, you can tell the result. So what is the probability of this one? Yes, this is 1, right? So why this is 1? How can we say without any calculation? Without doing any calculation, without doing this part, without doing this calculation, you can directly say this result. The result is 1. How can we say this? Can anyone tell me loud? Yes, this is the total area, right? Yeah, the lower limit is 0. Yeah, that's fine. The lower limit is 0 and the upper limit is 2. So it's negative infinity to infinity. So that's mean we are considering all the values of x, right? So we are finding the probability for all the values of x. So that's mean we are calculating the total probability. And we know that the total probability is 1. So that's why it is 1. Yeah, you are right. From the lowest limit to largest limit. And yeah, it is the full area. Yeah, you're right. Thank you. Okay, so now I'll give you 2 problems based on this density function. So what will be the area from and the last one is probability of x is equal 1.5. So what is the area for what is the probability for the first one? Yes, 0, 0, 0. What is the probability for the second one? 0, right? How about the third one? And how about the last one? Yeah, all answers are 0, right? Yeah, thank you. So you can see here for these values of x, the function was defined for 0 to 2. And we know that for the other values of x, the function is 0. So here negative infinity to 0. So that's mean the function is 0. So the probability is 0. And here 2.1 to 3. So x is above 2. So that's mean the function is 0. So the probability is also 0. And here also 2 to 100. And since 2 is included, but at a specific value of x, the probability is 0. So that's why this is also 0. So all of them will be 0. So all of them will be 0. Yeah, thank you. So in the for the discrete case, we have discussed some specific discrete distribution of the discrete random variable. And similarly, for the continuous case, we will also go over some specific distribution, probability distribution for continuous random variable. So, and uniform distribution is one of the distribution for continuous random variable. And we also have discrete distribution, discrete uniform distribution, but we'll not cover discrete uniform distribution in this course. We'll only consider continuous uniform distribution. So whenever you see in this course, whenever you see uniform distribution, you will consider that one as continuous uniform distribution, not discrete uniform distribution. Okay, so a continuous random variable is said to have a uniform distribution on the interval a to b if the PDF is defined by this function. So f of x is equal 1 over b minus a, where x is from a to b. So the x is defined from a to b, and the density function is defined by 1 over b minus a, the upper limit minus the lower limit. So if you have any density function like this, then it will be called uniform distribution. So why it is uniform distribution? This is uniform distribution because the density is equal for each value of x for which the function is defined. If, for example, if you consider a function, suppose f of x is uniform distribution and x is from 0 to 2. Suppose x is from 0 to 2. So what will be the density function? 1 over 2 minus 0. And if you simplify this one, then it will be 1 over 2 and x is from 0 to 2. Okay, now you see that for any value of x from 0 to 2, the function is always 1.5. So that's mean at each value of x, the function is same. So that's why it is called uniform distribution. So that's mean the density is distributed uniformly for all the values of x. And for the other values of x, the function is 0. So if you draw the graph for this function, then it will be, this is 0 and this is 2. So for example, this is, suppose this is 1, so it will be 0.5. So the height of the density function is 0.5. So it will be actually curved like this. And the other values are, for the other values, the density is 0. And the area under this curve will be the total area under this curve. So this is the area for this density function. Now we can check that the total area is 1. The length of this part is 2. And the length of this part is 0.5. So this is a rectangle. So if you calculate the area of a rectangle, then you know that the area of rectangle is length times width. So that's mean 2 times 0.5. So it will be 1. So the total area is 1. And you can see that for any values of x from 0 to 2, the height is always same, right? So that's mean it is distributed uniformly. So that's why this type of distribution is called uniform distribution. So if you consider another function, so for example, if I say x is random variable, and sometimes it is denoted by u, a to b. This means x is uniformly distributed from a to b. And if we have another distribution u, -1 to 1, so that's mean X is a random variable which is uniformly distributed from -1 to 1. And sometimes it is also denoted by UNI, or sometimes it is also denoted by uniform -1 to 1. Okay, so that's mean X is uniformly distributed from this value to this value. So here we have -1 to 1. So that's mean X is uniformly distributed from -1 to 1. So if we are given that X is a random variable and it is distributed from -1 to 1, so what will be the density function in this case? So what is the density function? Anyone? What is the density function in this case?
It's just -1 to 1. It's whatever. It's
Yes. Hmm? Yes. Negative. Yeah, X is -1 to 1. So what will be the function? Okay, so how do we calculate the function? Yes, 0.5. Yeah, you are right, 0.5. So that means it will be 1 over, the upper limit is 1 minus -1, right? Yeah, it will be 0.5. And X is from -1 to 1. So it will be 1 over 1 plus 1. And X is from -1 to 1. So it will be 1 over half -1 to 1. So that's mean the function is, density function is 0.5 and X is defined from -1 to 1. Okay, now we'll go over an example. Suppose that the reaction temperature X in a certain chemical process has a uniform distribution. So X is a random variable and X is the time, right? X is the, sorry, temperature. X is reaction temperature in a certain chemical process has a uniform distribution with A is -5 and B is 5. So that's mean X is from -5 to 5. So that's mean the function will be then 1 over B minus A. That's mean 5 minus -5. And X is from -5 to 5. So it will be then 1 over 5 plus 5. And X is from -5 to 5. So it will be then 1 over 10. And X is from -5 to 5. So this is the density function. So now we know the density function, we have to calculate the probability from -2 to 3. So how can we calculate this probability? So -2 to 3. So we have to find the probability from so the lower limit is 2, upper limit is -2. And -2 and 3 are between -5 and 5. So that's why you can consider -2 to 3. So the density function is 1 over 10 dx. So then it will be 1 over 10 times x, and x is from -2 to 3. Now we have to plug in the upper limit and lower limit. So it will be then 1 over 10 times 3 minus 1 over 10 times -2. So it will be then 3 over 10. This is negative. So it will be plus 2 over 10. So it will be 0.5. So if you simplify this one, then it will be 0.5. Do you have any question? And you can also see here, this is 0.5. Okay, so for this density function, if we want to calculate the probability from, for example, if we want to calculate the probability from -7 and if we want to also find the probability for probability x greater than equal 0. So can you calculate these three probabilities? This is uniform distribution, and you have to calculate the probability from -7 to 0. And okay, so there is another way to find the probability for the uniform distribution. So this is, and that way is very easy, very straightforward. So for uniform distribution, the distribution is, the area is rectangle, right? The area of a rectangle for uniform distribution. So for example, if this is -5 and if this is 5, so that's mean this is the total area of this density function, for this density function. Now we have to find the area from, and this height is 1/10. So this height is 1/10. So how can I calculate the total area? So, and this length is -5 to 5, so that's mean this is 10. So if you multiply the length and width, then you will get the total area. Similarly, we have to calculate the area from -2 to 3. So if our -2 is here and 3 is here, so that's mean you have to calculate this area, right? So that's mean area of this rectangle. And the area of this rectangle, the height, width is 1/10. So this side is 1/10, and this side is from -2 to 3. So that's mean 3 minus -2. So it will be 5. So this length is 5. So the area will be 5 times 1/2. So the area will be 1/10. So that's mean 1/2. So you can directly calculate the probability for the uniform distribution instead of doing integration. So similarly for these three pairs, you can directly calculate the probability, or you can do it by performing indefinite integral. So, okay, please tell me the results for these three problems. X is -7 to 0, x is 0 to 15, x greater than equal 0. Even without doing any calculation, you should be able to tell the results. Okay, so I got one answer, 7/10. Could you please explain me why your answer is 7/10? Okay, I think you calculated the length from -7 to 0, but you have to be very careful. The function is defined from -5 to 5, not from -7 to 5, right? So that's mean from -7 to -5, the density is 0. So for that part, the probability is 0. So basically you have to consider, for the first one, you have to consider actually -5 to 0, not -7 to, though we have here -7 to 0, but the function is defined only for -5 to 0. So that's mean you have to only consider -5 to 0. So negative 5 to 5. So for this part, this one is 1 over 10. And for the other parts, it doesn't have any height. The function doesn't have any height because it is 0. Only for from negative 5 to 5, the height is 1 over 10. Yes, it will work if a is negative 7. If the function is defined from negative 7. Yeah, you're right. But the a was negative 5. So the function was defined for negative 5 to 5, not from negative 7 to 7. Yeah. So I got a couple of answers. 1 over 7. 1 over 2 is the correct answer. You can see here, this is uniform distribution. So this is 0.
When the
Mhm. Yes. Yes, you're right. For uniform distribution, a is the lower limit and b is the larger limit. Yeah. And for the other values of x, the function is 0. The function is only defined for a to b. So now you can see from negative 5 to 5. So this is the 50% of the area, right? Sorry, negative 5 to 0. This area is the 50% of the total area. So that's mean the probability is 0.5. And similarly from 0 to 15. 0 to 15 means 0 to 5, because for the other values of x, the function is 0. So that's mean for this part, this is also 0.5, right? However, this one, x greater than equal 0. So 0 to infinity. So that's mean this is also 0.5, right? So all the answers will be 0.5. Is it clear, or do you have any question? Any question? Okay, so if you do not have any question, then we'll move to the second section of this chapter, which is cumulative distribution function. So from discrete random variable, you already know how to calculate the cumulative distribution function and what is cumulative distribution function and what is density function or mass function. So cumulative distribution function will give you the cumulative probability. So that's mean if f of x is a function that, and it is denoted by capital F. So f of x is called the cumulative distribution function. This is actually the probability of x where x is less than equal x. So that's when this is the cumulative probability up to the value x. So if you have f of 3, so that's mean this is the cumulative probability of x up to the value of x is 3. And if you look at the curve, then for example, if our density curve is like this, and if we have, so this is 0, and if we have a density function, so here we have f of 3. So for example, if 3 is here, so that's mean f of 3, it will give you the area of this part. So that's mean it is giving us the cumulative probability. So you can also use this function to calculate the probabilities, because f of x will give you the cumulative probabilities. So here we have x less than equal a, which is actually f of a. And this is also same as probability of x less than a. For continuous case, they are same. Both of them are same. But for discrete case, they are different. And if you have probability of a less than equal, sorry, x greater than equal a less than equal b, then it will be actually f of b minus f of a. So why f of b minus f of a? So suppose this is our a, this is our b. So this one will give you the area on the left side of b, and this part will give you the area on the left side of a. So this one is f of a, and this one is f of b. But we want to find the area between a and b. So f of b is giving you the area on the left side of b, and f of a is giving you the area on the left side of a. So if you subtract this area on the left side of a from the total a, then it will be the area between a and b. So that's why probability of x, where x is between a and b, is equal f of b minus f of a. And this is also same as this area. This is also f of b minus f of a. So in continuous case, you do not need to care whether there is equal sign or not, whether x is greater than equal a or whether x is greater than a, it doesn't matter, whether it is strictly greater than or greater than equal. So it will give you the same area. But in discrete case, you have to be very careful about this notation. Okay, so now if you are given the density function or PDF function, you can calculate the CDF. So for example, if you have the density function f of x, then the CDF f of x is actually minus infinity to x f of x dx, because this f of x is equal probability of x less than equal x. And we already know the definition of this probability for continuous case, which is negative infinity to integration of the density function, and x is from negative infinity to x. So the CDF function is equal negative infinity to x f of x dx. And so this is the CDF function. And if you are given the CDF function, you can also calculate the PDF function. The PDF will be the, CDF is the integration of PDF. So PDF will be the differentiation or derivative of CDF. So that's mean if f of x is CDF and a small f of x is PDF, then this one is equal the derivative of the cumulative function. So using the CDF function, you can also calculate the percentile. You can calculate median. You can calculate first quartile, third quartile as well. So we'll discuss it later. And in discrete case, we have calculated the expected value, and the expected value of x for the discrete case was summation of x times f of x. So that's mean you have to take the product of x and the corresponding probability of x, and then you will add them together. Here the definition is exactly same. The only difference is, since this is continuous, so instead of taking the summation, you will do integration. Okay, so the expected value of x is equal negative infinity to infinity x times f of x dx. So you will take the integration of the product of x and f of x from negative infinity to infinity. And similarly, if you have a function of x, h of x, and you want to calculate the expected value of this function of x, this is also negative infinity to infinity h of x times the density function dx. And variance is also similar. So from the previous class, from discrete, for discrete random variable, we know that the variance is expected value of x minus mu square. So in discrete case, it was summation of x over x minus mu square times f of x. But for continuous case, it will be x minus mu square. So it will be actually integration from negative infinity to infinity and x minus mu square times f of x dx. So this is the variance of random variable x for continuous case. So usually we are not going to use this formula to calculate the variance. There is another formula which is called computing formula. So we can derive that formula from this one. So usually we'll use this formula to calculate the variance. Then it will take the square root of this variance to calculate the standard deviation. So today we do not have enough time to go over more examples. So in the next class, after the exam, after your first exam, we'll continue this chapter again. Okay. So I'll stop